All right. Hello, Julian,
Hi, JB.
and welcome everybody to the 12th live stream of the Music Hack Space. So today I'm excited to welcome Julian Woodward, who has been working over the past 5 years on this software that you just saw a glimpse of called Tweakable.org. So Tweakable is a result of his hard work as a hobby first, but then for the past year or whereabout has been his full-time occupation. Is that correct? You've been working for about a year now, full-time on it?
Yeah, that's right. Since last September, I kind of gave up the day job dangerously to devote myself to this project. But I think that will probably have to, um, go back to something else soon.
Right. And what
But
was the inspiration for you to build Tweakable?
well, I've been a painter and a musician and a computer scientist, software engineer for most of my life, and I wanted to find a way to combine these things and to see if I could use computer programming paradigms in the musical and visual domains. When I was a boy, I had an amazing system, a software music system called Music 5000. I was very lucky to have access to a BBC Micro, and on an amazing 32K, you could compose music with a staff editor. But it also had a programming language called Ample that enabled you to um, build up a musical composition by creating modules containing scripts, and this just sort of blew my mind to the possibilities of being able to create music with a computer programming mindset, and the possibilities are sort of extraordinary. So that's where I um, uh, came from with Tweakable.
And so to date, you have presented this at IRCAM, at the Forum IRCAM in Paris. That was a few months ago, just before the
That's right.
lockdown,
Yes, just in March. Yeah, just the
just in
beginning of
March.
March. I just managed to escape back to London um, just before the lockdown kicked in. So yeah,
And before that, you had presented it at a conference as well
in Norway. Yes, at the
in
Web
Norway.
Audio Conference in Trondheim. Yeah,
Right,
that's
right.
right.
But it's the first time this is publicly demonstrated.
Indeed, it's the first public showing, really. So yes, very excited to be here to share it with you.
Yeah, well, I'm very excited as well to have you. And I'm going to bring back the screen, so it's going to bring audio back as well. And this is one of the complex parts that you have in your examples. But maybe we can start with this, and you can maybe explain to us how that works.
Sure. Okay. I'm just going to turn the volume down a little bit. So what is going on here? There's a function initially that is the source of everything. So this is a function which is just math.sine x. You can change the function. I like using trig functions because they give you lots of data that you can then manipulate and put through different transforms and things. And then, so this creates a set of data based on a range of x on the trig function. And then that is going into this object here, which creates three voices from the sequence of data generated by the function here, which is determined by this graph, which simply defines the spread of the notes for the polyphony. This just gets rid of duplicate notes, and then I'm splitting out the three parts again and defining the ranges for each of the parts. So if I fiddle around with those, then it affects the range of the range of each of the parts here. And then finally they go into the sequences, and the sequences are doing different things with the information. So this one's playing the sequence that's 384 ticks, which is about one note every bar, and this is playing much quicker. It's 24, which is quavers, and the duration of the sequence is different as well. So this is only taking the first 6 steps of the array, and this is taking the first 12 steps of the array. And then they go into a further transformation to add some expression to the information that's coming out with velocity and length. So the sequence comes in here, and depending on the length of the array, you get a sort of pattern of accents for velocity and a pattern of longer and shorter note lengths, and then they all go into a chord pattern, which is just a simple Lydian chord pattern, but you could change that to C minor, G7, for example. So that's that more or less covers that one.
All right. So maybe just to go back for a second to what people have just seen, because an online programming environment could mean a range of things, but in this case you have a very strong paradigm of patching, and there's a flow that's graphical, but also you have these elements of scripting, which we've just seen for the chord patterns that you.
Mhm.
So could you talk to us a little bit about how that works?
Yeah, of course. Well, the visual paradigm of patching, as you mentioned, is similar to what you have in Max MSP, which I'm sure most people watching this will be familiar with. However, unlike Max, this is not a programming language as such. This is really a visual way to write JavaScript. So when you're dropping the nodes down into the workspace and connecting them up, you're writing JavaScript under the hood. And so you have also these scripting windows. In this case, it's a custom script to interpret the chord patterns, but you can also write JavaScript code to extend the functionality that exists. I'll show you probably
All
some
right.
of that in some examples a bit later.
Okay. And so that brings me to another question, which is, who did you mean to write Tweakable for? Who is your target audience?
Well, I think people who are interested in experimenting with music and finding different ways to compose music and interact with it and build apps that people can interact with. I think probably anybody who uses Macs probably would be interested in Tweakable, I think. So I would say university students and academics, but I also would very much like it to be used in an educational way for children to sort of see how maths and music can interrelate as well.
Yeah, I could see that. It's great to teach or to understand trigonometry when it impacts music notes that are being played. For sure, I could see how the
Yeah,
appeal
I
to
never
that.
realized how interesting the tan function was until I started playing around with the with it and translating it into notes. It's quite expressive.
Indeed, and so you have a range of examples on your website, which people can see
Yeah,
on tweakable.org. But it'd be great to get a little bit more into that to show all the
yeah,
possibilities.
yes. Well, so with Tweakable, one of the exciting things I think is for people is that you can quickly build a musical machine on the web that people can interact with and embed into their own blog or website. I've mentioned about visual JavaScript. So that's a bit about algorithms. I find that algorithms can be extremely useful for creativity. You can use an algorithm as a sort of recipe or a rule system to suggest completely fresh ways to approach things. And far from the computer doing all the work for you, you're inventing the rules for the system. So you're doing the creative part, and the computer is doing all of the sort of boring stuff, if you like. And the thing with an algorithm is that it's really great fun to interact with, because very often you can change the output dramatically by just tweaking a few of its parameters. And you can invite the audience into the creative process to tweak the constraints of the system, blurring the traditional boundaries between experiencer and creator. So I won't go into too much detail now about the mechanisms inside Tweakable and the various components. I'll jump straight into some more examples. This is another example exploring some data from the trigonometric function. This is the tan function I mentioned earlier. So with just one function, I have different mappings that control the output in different ways. So I'm sampling the data differently in each one. So start and end x is the range of x for that function. I could add some interactivity by making that math.tan x times y, and then adding y and connecting a knob to that. So you can make JavaScript functions that you can easily interact with in this way by writing code and connecting knobs and sliders to the inputs. Rhythm sequences are really useful because not only can they generate rhythm, but they can be used to switch things on and off and automate all kinds of other things. I've been using the Euclidean algorithm a lot. I'm sure some of you know about Gottfried Toussaint's paper, The Euclidean Algorithm Generates Traditional Rhythms. So with a couple of parameters, number of spaces and fill, you can create some really interesting rhythms as the space filling algorithm tries to fill the spaces as evenly as possible with a number of notes. And when the ratio is uneven, you get gaps occurring, which create interesting rhythms. And this component controls presets for each of these components, which I can also make play by itself, transition between the presets.
So I just had a question about this one that you just showed. Yeah. So you had all the X's, and they represent the moment in time where, like in a typical drum machine, I suppose, would work. Is that correct? So if
yes.
you
Yes, sorry, that's represents an onset pattern. So the X's represent the hits and the dots represent the rests, if you like. So you can draw them in.
Well, you can also draw on it.
that.
Yes, yes, yeah. Well, this is great, and I mean, and then just to interject as you present, I just wanted to highlight the fact that this can be extracted, embedded into something, so you can build on top of this a user interface, and
Yes.
then bring that into any website, and that opens very, very interesting possibilities, which I'd love to elaborate on maybe later when you've showed more about the possibilities.
Yeah.
But
yes, sure.
That's I find very exciting.
Yeah. So other ways to use rhythm. Actually, I'll open this one separately because this is quite fun to play around with. So here I've got a piano and a Celeste instrument, again driven by functions, but here I've got a multiply component that is creating a rhythm from the initial sequence. But instead of if I wanted it to just create a rhythm, then I could change the off to 0, which represents a rest. So in this way of sort of destructuring rhythm from melody, you can do quite a lot of fun things. But because I've got the 0 greater than 1, I'm getting other notes in there instead of just zeros. And the range is controlling the output to got some I think the problem with the stream. And then I've got this velocity component that's interacting with the sequence to add expression. So if I've got two notes, two elements in the sequence, then it's going to create a sort of da-da-da-da-da-da-da rhythm, and so on. So you can create different kinds of expressions. And this one creates rhythm from the initial function in similar way, but just a different style. Instead of multiplying, it's a sort of a pipe. Yeah.
And you can also control the length of the window, I imagine, so that because the examples that we've heard where the repetition was kind of short, but I imagine you can also have like a much longer sequence.
Yeah. I mean, you can play about with how long they are, and that's actually an often fun. Yeah.
Is there a limit to how long that sequence can be?
Well, if you've got a supercomputer, you can have it as long as you like.
Oh,
really
the longer it is, the more CPU power
because
it's going to take?
and it depends what you're doing with it, because obviously if you've got a very, very long array and you're doing transforms on that, then there's going to be a performance impact. So generally, I like to keep the sequences fairly short and work with shorter sequences, because also it makes it more flexible and more interactive. Okay, so here's another example. This is another example of using rhythm to do other things besides just create rhythms. I've got a rhythmic pattern here, which is controlling the trumpet to start and stop the sequence. So as where the crosses are means that the trumpet's going to play, and where the dots are, the trumpet stops playing.
Well, someone is putting a word of caution here. It was just playing. It was a jazz patch, which I assume is the one that we're listening to now, and the trumpet blows them up. So I don't know if it was a good thing or a bad thing, but they said also it was inspiring. So I guess it was a good thing. Thank you for
Okay.
trying it out and commenting.
In this example as well, I should just introduce the idea of modules. So here, this is a module, so you can encapsulate functionality and reuse it, packaging all of these objects into a box and define your inputs, have all your behavior, and reuse that anywhere. So you've got a trumpet there. You could create another one, copy and paste, and you can change its parameters and similarly, this drums is a module as well. So if you open that up, it's just a very simple module with 3 rhythm components going into jazz drums. But you can edit the rhythm quite easily. And here I have, sorry.
No, go on.
I was just going to say, here's another state component, so you can store presets here and change them manually or have them cycled through. When that play button's lit up, it means that it's going to cycle through each preset in a sequence.
Nice.
And
how about
over
samples?
Well.
How do you work with samples?
Well, I have some samples that I've uploaded, free public domain samples that are available. So this is what's it called? Salamander public domain piano sample, really nice. There's no way at the moment for you to upload your own samples, but that may come in the future. But you have a lot of instruments available just out of the box. Harp, piano. I mean, these are just ones that I've put there because I use them often. But if you choose the sampler, then you can well, you can see the samples here. Yeah, that's a bit loud. You can see the samples are available here, so that you can work out which MIDI notes correspond to samples, and you can select from quite a big range of samples here for different instruments in this particular sample set, clarinet or yeah. So
Right.
that one's quite fun. Let's have a look at something else. Yeah, combining sequences. I've seen some of that already. This is the oh yeah. So pitch modulations is very simple. We're just taking an initial sequence defined by a function and a secondary sequence, a modulator sequence into there, and getting a more complex function sequence out of it.
So it is kind of the principle of FM synthesis applied to
Yeah,
MIDI
it's
notes.
a similar concept, I believe. Yeah, just you have a kind of carrier. You have a waveform that acts as the carrier, and then that gets modulated by a secondary wave, and it's a similar idea. Yeah.
Very interesting.
And this one, so this is an example of a user interface that's been created. So you have, again, modulation, but primary rhythm and a secondary rhythm that is kind of interwoven into the primary rhythm. Here you can adjust the kind of dynamics and rotate the pattern. Some of these numbers are sort of magic numbers that create. I mean, 8 spaces and 5 notes is always good. But if you have the same number of, well, if the number of spaces divided by the fill is 2, then you just get an even distribution. Nothing interesting happens. So just one every now. But if you make it uneven, then you get something more interesting happening. 8 and 3 are good as well.
What intrigues me in this example is the user interface. So in this screen, we are completely away from how it's built, and there is an interface to use it. So
Yeah.
how does that work? How do you connect the user interface element to the actual engine? Because I
Yeah.
suppose people will be able to build both.
Yeah, I mean, in this case, I have 2 modules. Well, they're 2 instances of the same module, in fact, primary and secondary. And each module has its own has a user interface defined, and that's defined simply by creating a panel object, and then, well, actually a few panel objects. It's very simple. You just you create a panel object, you select the objects you want on the panel, and then you just define whether you want the panel to be horizontal or vertical, and you can define the spacings here. So when you have a more complex sort of grid layout, that will be comprised of a sort of panel containing other panels, sort of a vertical panel containing subsequent horizontal panels, and so on. So you can access the panel screen from up here. So that's the node graph screen. If you go to the root, then you can see and then you can adjust for responsive behavior. So on the mobile, it collapses down to a carousel, and when there's enough width, it will show both at the same time.
Oh,
So
this is great.
So to have that behavior, you also need to define a carousel object, which I've done here. So the carousel just has the primary and secondary modules, and in the carousel, you can define the minimum width for the carousel. So that's the minimum, the point at which it will collapse to the carousel from being both of them at once. So if I was to reduce the minimum width, then it shows both at the same time on the mobile version, which you don't really want. So you want at least, I don't know, 300 width for that UI to work effectively. So
well, that's super interesting. We have a question coming in from Facebook, which I'm going to bring here from Christian. Thank you, Christian. Can it send out MIDI data?
Absolutely. In fact, it started off, when I originally began this, it started off purely as a MIDI generation tool. I started off as a Node.js application, in fact, without a UI. And so, yes, it can. And there's quite sophisticated ways of controlling the output of the MIDI. I mean, there's yeah, I mean, it started off as a scripting language, and if you can output MIDI just by putting a MIDI output, and then you can wire that up to your favorite contact, VST or whatever you want, or Ableton, anything. So yes.
Great. Thank you for this question, Christian. And if you're listening and you have any question from Julian or Julian, don't hesitate to post them in the chat either on YouTube or Facebook, and we will be able to see them and answer them here. So yeah, what's next, Julian? I mean, I know there's video, which I can't wait to get into, but you might have more things on the audio side that you want to show.
Yeah. Let's have a look. Get back to the. So the Canon one was that was the example we used opening. So this is a simple example where I'm just showing how you can constrain events to a chord pattern. So so C minor, F minor, G7. If we were to get, we could, I mean, if we just get rid of it, then it's just well, it's C minor because that was the last chord that it played, I think. So it cycles through. If you put a chord pattern in, it'll cycle through all the chords according to the parameter here that defines the speed of the value of each step.
Is that random or is it deterministic? The way the chord pattern progresses as you move the slider.
Well, it's simply defined by this. So 96 is basically 2 beats. So it'll spend 2 beats on each of these. So if I was to reduce that to 24, then it'll spend each of the chord patterns will be a quaver, so it will go through each one much more quickly. Which is too quick for a chord pattern, which is why I've got 96. But yeah, it cycles through, and you could, if you use the slash, then you can extend the length of each one as well. I mean, there's a syntax that for this simple syntax to change the duration of the notes of the chords. It's similar to the melodic script language, which we'll see in a minute as well.
Right. I have another question, if that's okay.
Yeah.
Like early on, we've seen the trigonometric curves that you've been using to feed into a sequencer. How is it different to work with a slider here, where the value is input like this? I mean, Pretty
Yeah,
much the
because
same, but one of them is going to
yeah, it's
evolve.
a good question. Thanks. Yeah, well, when you do this, you're obviously interacting in real time, so there's no sort of store of data that can be manipulated other than, well, it can be obviously manipulated, but it's being manipulated right at the last minute before it actually goes into the piano. So the difference is that the data here comes out as an event and it's not stored, and you can't do the same kinds of things as you can do with a sequence. You can't say reverse, like with a sequence you could do all kinds of different manipulations, whereas with this, that's why I've used this green color instead of blue, because blue is usually a sequence, and well, there's always a sequence. And yeah, there are still things you can do here. You can put delay in. But yeah, basically the data is just a single item when it's coming out of the slider, whereas when it's coming out of the function, when it's coming to the sequence, it's a list of numbers, a whole set of data that's
Right.
going in, and then it needs a
And
sequencer to convert that to events.
this data is MIDI information.
No, it's not MIDI information. I mean, it's just JavaScript objects. So when it goes out to MIDI, then it gets converted to MIDI data, and when it comes in from a MIDI device, obviously we receive MIDI. I have played around with controllers as well, so but I haven't kind of used that for a while. So yeah, it'd be nice to explore a bit more, again, using MIDI interfaces to use with knobs and sort of controllers to control it. But as I have explored that in the past.
Right.
This is a more complex. Do you want to see another sequencing example just quickly? This is quite a complex one.
Sure. We also have a question related to education, but we'll answer
Yeah.
that just after.
Okay. Yeah. This one, originally I created a kind of a user interface for it, but I realized that in doing the user interface, as you say, you kind of hide all of the inner workings, and something gets lost when you do that. And so I wanted to sort of just expose the innards again, because you kind of forget how the whole thing works. So yeah, it kind of plays on and on and on, and it never repeats. It's always continually generating new. And in fact, about 2 or 3 minutes in, it gets more interesting. But I don't want to wait for that. So it's using the similar things we've already discussed, but combining lots of things together. We've got a state storing the range of the function values, going into a polyphony object to create multiple parts, and then rhythm, which is also controlled by a state management thing, so that the rhythm's continuously changing, and also the phrasing with the velocity and length sequences is continually changing, and because they're all of these state machines are of different lengths and playing at different speeds, you get a continuously overlapping pattern. So the output is always sort of kind of unexpected, when you can't predict it really. And then of course you've got the chord pattern, which is constraining all of that data to fall within what sounds like something nice, or something that we're used to hearing. Some spaces in that. And then down here, I'm using a graph to control the dynamics of the piano, so it sort of swells in and out expressively. And I've got some reverb on here to just create some effect. You could add more effects if you've got. Yep. So
I didn't realize there was audio effects as well. That's very complete. I love the oscilloscope you showed at the end as well.
I've got a few more audio stuff to come. I mentioned briefly the melodic script. This is based on the music programming language AMPL that I mentioned right at the beginning. That was an inspiration. The music synthesizer from the 1980s. I derived this scripting language off that because it's just really, I just thought it was so elegant. So you can just have letters of the alphabet corresponding to notes of the scale, and it's just a really easy way. I mean, it might not look that easy if you're not used to it, but it makes sense, and you can have accents and legato to join the notes together. And in this example, you can draw the dynamics of each part, make them sort of fade in and out. And commas separates, so you can have polyphony in the script. Yeah, that's that.
Well, this part is fascinating. So it's really bringing up elements of live coding where you can pre-build your small machines and then interact with each of them in polyphony to create like a complex thing going on.
Well,
that's very interesting.
Yeah, I really want to spend a bit of time coming up with some nice interfaces for live coding. I just haven't really had time because I've been doing so many other things, but I definitely want to sort of build on the live coding thing a bit more because it's really fun.
Is there an approach in live coding that inspired you in all the available software there?
I was totally blown away by tidal cycles, and I did incorporate at one point some of the tidal cycle language, but in fact in the end it didn't make sense because it started going down a different sort of paradigm, and so I ended up paring the whole melodic script thing back a lot and just working with the sort of system I have, which is a kind of a visual system of using transforms and mapping and filtering instead. But yeah, tidal cycles is fantastic.
Okay. Just want to say, Rani, if he's still listening, he had a question about education. I think we might, we might ask, answer it now. I suppose we did. You did mention education before, but I suppose this question might have also bring up all the possibilities in education where music can be taught, but also programming. And as you said earlier, this is kind of a tool, a visual tool to build JavaScript. So it could both be a tool to learn math, maybe music, and maybe also programming. Did you have a preference over which this should be useful in education?
Well, no, I mean, I'm really inspired by the educational use case. I would love Tweakable to be used in an educational capacity, and I think there's a lot of scope for it. There is just a vast amount of educational software already existing, so I'm not clear. And I think also when you build educational software, you have to fit it into existing syllabus. I think that was the impression I got. So it would require a great deal of work to sort of package Tweakable so that it could be used in that context, I think.
Right. So yeah, okay, understood. So I guess it's not going to be your primary destination, but nice to have when it.
Yeah, I mean, it's not the primary destination really. I think the primary destination for me has always been the idea of creating art on the internet. That's always what's kind of motivated me. But as I say, the educational capacity is fantastic. I just haven't got time to do all of that. So it's, I need to get a team or something to do that. This is another audio example, which is quite fun. This is some graphs controlling various parameters of an FM oscillator. So the frequency, modulation index, and harmonicity of an FM oscillator. So you can draw on there. Something weird's happened. I think it's. Don't know what's. Yeah, it seems a bit strange. Anyway, the idea is that obviously you can take any object and automate the properties through graphs, which you can draw on and also write functions to control. And obviously, let's see, obviously add a knob if you wanted to control it like that. Anyway, yeah. And this is a kind of a nice interactive example of a similar thing with a touch slider controlling the same type of instrument. Sounds like something from Doctor Who.
This is great.
And this is another user interface, just simple. Sorry, that's a bit too loud, isn't it? Let's turn that down a bit. Yeah, the levels are a bit off. I might have turned one of them down too much there. Again, we've got presets on the side there.
There was a question from Ginger. Hello, Ginger. Uh, she was wondering how this behaves on touch device. Like she was referring to the one that you showed earlier with the
Yeah,
sign.
it works well on on iPads and iPhones. I mean, you need a reasonably decent phone in terms of kind of processor to be able to do it, but it does work quite well, and it's nice and tactile on obviously on the touch device doing those things. Um, well, I won't show you, but you can try it out. It does work quite well. Uh, yeah.
All right.
So I
Yeah,
just
thank you
shall
for
I
that.
just do a
Yes.
few video examples?
Yes,
Um,
please.
so yeah, um, so there's I've incorporated this amazing video JavaScript-based video synthesizer called Hydra. Some people who have done some live coding, or some people may know about it. But again, you can create modules to encapsulate the behavior. So I've got a couple of modules that generate stripes here, and then I can pass them through functions to rotate them, and um, various different things, and then you can expose knobs and sliders to the user interface. Um, so that's that one. Similarly, this one kind of inspired by British painter Bridget Riley. This one uses feedback. So one of the really exciting things about Hydra is when you use a buffer as an input, so it continually regenerates pixels based on that buffer, and you get this really interesting effect. I can't really fully understand how it works, but it's pretty amazing. Um,
So if someone wanted to build a user interface with maybe a clickable, touchable point on that painting to change the parameters and hide away all the inner workings, it would be possible. Then you just embed the code into a web page. Is that?
yeah. Well, the embed code is just here. So if you click share, you can just copy the code to the clipboard there and paste that into your own website or homepage. So you can come into Tweakable and create an account. That's only needed so that there's somewhere to store your stuff, and then you'll have a URL where your Tweakable becomes available, and then you can just paste that into your homepage.
This is amazing.
Right. This is another fun one. This is based on some of Nato Hieda's book. He's written a really useful article about, well, a book, but also a web page about Hydra. But here I've got some modules again that generate some pixelated, to sort of split out the RGB components and kind of put them back together again. So you can change the amount of pixels in there, and a little bit of JavaScript in there to do a conversion. And you can easily sort of switch bits on and off, which makes it really easy to see how things are affecting the output just by clicking the on and off buttons there. So it makes it's I mean, the live coding in Hydra is great, but I find it's a little bit easier to work with because you can sort of visually see how everything's kind of connected and working together. It's quite hard to understand otherwise, I find. But another one, again, that's inspired by one of Nato Aida's idea, book from his book. get some nice moire patterns from some of it when the frequency's turned up a bit. This one is an interesting example of feedback, video feedback. You get some very beautiful and complex patterns from this.
So how easily can you combine parameters to control both audio and video at the same time?
Yeah, I mean that's interesting. I mean it's an area that I haven't explored a great deal yet, but I have this final example, which is a bit of fun, which has got. Oops! Oh no, that's the that's the wrong thing. Which is a bit of fun, which does do that. Well, in fact, to tell you the truth, the music is sort of separate from the video. They're not interdependent, but you can simply connect the same sequence to control a parameter of a video effect or oscillator as you would to the music. But the difference is that the when you're controlling something visual, the transition between each event is more kind of jarring. So you need a way to sort of smooth the transition. I mean, this array it automatically interpolates the data so that you can move from a simple sequence which is defined here just as a set of numbers to something smoother. And if you want to try and synchronize the music with the video, then it's a bit more tricky, because if you're interpolating or smoothing the values, then the timing that the values get sent out has to be slightly different. So it's an area that I'd like to explore more anyway, I think, to cut a long story short. So I think that more or less concludes my set of examples that I have for you today.
Great. Well, if there's any question on YouTube or Facebook, please post them and we'll look at them. I have a lot of questions for you. One of them that stems also from the time that we spent before the live stream to work out the best way to share a web page within a web page, and all the performance issues that came with the testing of that.
Yeah.
And so my question is around performance, and how big a limitation it is today versus what it will be in 2 to 3 years. Do you think this is? Can you talk about performance a little bit?
It's a constant battle, really, performance. I mean, I'm continually optimizing and trying to see how to optimize and refactor and ways to make it work more efficiently. I mean, I think when you're running video and you're doing live video mixing alongside music and live audio synthesis, it's going to put a strain on the system inevitably. I'm not sure in 2 years' time whether computers will be significantly more capable of dealing with those loads, because I heard that Moore's law has more or less sort of stopped now. So because I don't think they can get enough processing power into the chip and keep it cool enough at the same time. So I think it's a cooling problem rather than anything more than anything else. I think the process is just overheating.
Well,
So
hopefully,
I'm not sure.
hopefully specialized chips will help, like such as video, graphic cards,
Ah,
and
yeah,
and others. Could help get more load,
definitely.
more load on
And
it. So,
and the video components in here do support hardware acceleration because they're RegGL, which is hardware accelerated. If you have the graphics cards, then they'll be used. So that's fantastic. Um, the There's a few problems with the sampler on the iPhone that I haven't been able to something to do with buffering samples on the iPhone, which I can only assume will be something that will be addressed in the future. Uh, but I have an iPhone 10, which is quite powerful, and most things work really well on there, apart from the sampler, which it works for the first 2 or 3 minutes and then starts crackling up, giving up after a while.
right, right. Okay, so performance was still an ongoing issue, and the
Yeah,
reason is that you are running everything within the browser as opposed to running native on operating
yeah,
systems.
yeah. Definitely, there's more performance constraints from being in the context of the browser. I can't have multi-threading at the moment, so if that becomes supported in the browser, then that may be a game changer.
Right. So I suppose it positions those limitations position Tweakable more in the domain of uh, simple experience that makes audio and video or use either. Well, simple as in uh, designing an interesting, but with the complexities that's probably will be limited in scope, but that could be embedded into any interactive web page,
Hmm.
as opposed to doing a big installation of the Tate Modern or
Right. Yeah. Sorry, what I didn't quite get the question. What the question was.
well, it's maybe more common than a question, but like
Right.
um,
Okay.
but
Yeah.
like within this realm, and maybe going back to a question I asked you earlier about who is it for? Is it for web developers, or is it
Yeah.
for musician, or the overlap of the musician who are also JavaScript developers?
Hmm. Yeah. It's yeah. I should have an answer to that, but I think, as I said, it's probably whoever's interested in doing creative things with code, who's interested in music and visual um, stuff. Whoever uses Macs probably would probably enjoy this. Yeah, yeah.
Do you have plans to open contribution to open the source code to contributors, possibly, or open source a part of sandbox part of the experience so that others can share either the
Mm.
creation or improve by adding plugins or effects to
Yeah,
Tweakable?
that may happen in the future, but I'm not doing it at the moment because for a number of reasons, it's quite a job to just maintain an open source project. Um, it's something I'll consider in the future. Yeah, I haven't made a decision on that yet.
Right. And for anyone who is watching now or will be watching later, how to get started and join the community of people who use Tweakable?
Yeah. Well, if you just go to the home page and do you want to do the screen
Yeah,
on it? Put the
sure.
screen on again. So at tweakable.org, if you just go to the home page, you can't see that address bar, but if you just go here and if I just sign out, then you can do register, and then you just fill the form out. That gives you a space in which you can save your work. So your username will be in the URL as sort of the context, the namespace of your stuff. Click register, and then you can just go straight ahead and create a new project. So if I sign in, then you get a sort of profile page here, which I will develop a bit more, and then you can just click start to create a new project, and then you can choose to start with a blank canvas, or you can just open one of the examples and play around with that to get an idea of, and just sort of hack it apart, change it, and save it as your own one, and then go from there.
And for anyone who doesn't create an account, they can still use the website and do
Yeah,
modifications, but these will not be saved. Is that correct?
you just won't have anywhere to save your changes. That's really all. I mean, and it is quite nice to be able to save things you're doing. Um, so yeah, you can still go in and play around with things that other people have done.
Right. Well, this is great. I mean, I'm not seeing any questions popping up, but um, is there any last things that you want to tell us about the next step for you and what to expect in the future?
Don't think so, really. Yeah, I mean, at the moment it's in a sort of beta testing stage, so it'd be great to get people trying it out and feeding back on it, and any feedback that people give will inevitably feed back into the development of the of Tweakable. So it'd be really nice to get people on board and using it.
All right. Well, thank you very much, Julian, for taking the time to show this, and we're very proud that you chose the Music Hackspace for the first very public um, discovery of Tweakable. I can see certainly music hackers everywhere, use some of those code to make exciting and interesting interactive website. So good luck with everything, and I hope that we can stay in touch and that this community will thrive and grow.
Great. Well, no, thank you so much, JB. It's been a real privilege to be able to be here to show everybody. So thanks.
You're welcome. And thank you everybody for watching, and I'll see you on Thursday. Goodbye.
Okay. Bye.